Okay. All righty. Good afternoon. Good afternoon. All right, so we have switched from soil to talking about air and wind patterns. So last class we were talking about the layers of the atmosphere and what's going on in each layer. Today we're going to talk about global wind patterns. All right, so if you would take a look at 4.5 in Canvas while we're waiting for some few more folks to log in, and then we'll get started. We got quite a few things to do today. We haven't done a gizmo in a long time, so I'm going to introduce a gizmo to you today. And so there's quite a few things open for y'all to do. I had already opened 4.5 in the AP Classroom, so you can do that. I wouldn't worry about that today, because today I want you to start working on the gizmo. So, but it is open for those of you who wish to go ahead and get started on that. I did so right behind this, after we watch the video, the FRQs are now in for 4.4 and 4.5, but again, I'm not asking you to do that. It's available right now, but today I want you to do the gizmo, which is also, and I'll talk about that after everybody's in, but that's also loaded as well. All right, so right now, all I want you to do is to read over this section on global winds. In particular, our focus is on the Coriolis effect, what it is and what it causes, and all the different kinds of patterns that are involved in this effect. If Finding Nemo is one of your favorite movies, when they talk about the current that they swim in to get to Australia, that's going to be mentioned in this activity as well. That's a real thing. That's a real thing that they swim in to get to get Nemo where he's, or get Marlin to where he's going. Not Nemo, but um, that transcurrent that they ride is a real thing. So we're going to be talking about those as well. So I'm gonna give it another minute for folks to come in. Not missing, y'all did a good job of coming in on time today. So, and give it another 2 minutes. Wait for folks to come in, and then we'll get started. Just missing about 3 people. All right, the other thing I want you, as you're reading, I want you to give your attention to this particular map, because you do have to be familiar with the order of the way these cells appear on the Earth and what they do. So this map has little buttons that you can push for you to read about each type of trade winds. There's a lot going on in this particular unit. All righty. All right. We're almost there. All right, good afternoon. Good afternoon. If you just came in, we are in 4.5 today. And as always, we're going to start off with Mr. Sneeds. But then after that, I want to, instead of doing AP Classroom today, I want you to do a lab. Y'all haven't done a lab in a minute, so we're going to do a Gizmo lab. And I will walk you through that after the video. But again, and the activity is about the Coriolis effect, so understanding how that works. So while you're watching the video, please give your attention to what is the Coriolis effect and how it works. Okay. That being said, like I said, I'm giving everybody a chance to get in. Everybody else is late. And usually when I put these in, they do not start with the commercial.
5, which is global wind patterns. So we'll be learning how the basic properties of air, as well as how the rotation of Earth, give us the wind patterns that we see on Earth, and how they're also responsible for the weather patterns that we see.
Uh-oh, hold on. I accidentally logged out of the share. Need 1 minute to get it back. Alrighty, here we go.
We need to understand 3 basic factors. Those are the intensity of energy from the sun, properties of air such as density, and the spinning of the Earth on its axis, which produces something known as the Coriolis effect. Our suggested science skill to practice today is explaining relationships between characteristics of environmental concepts or models that are presented visually. So as I mentioned, the first factor that determines atmospheric circulation is how air's density changes under different conditions. So the first property of air related to its density is that warm air is less dense than cold air, so it rises. If you've ever been in a house with an attic in the summer, the difference in temperature between the attic and the basement is a really great example of this property. We also need to understand that warm air holds less moisture than cold air. So think about how dry and cracked your skin gets in the winter versus summer. That's because cold winter air holds less moisture. Now, another factor we need to understand is that as warm air rises, it cools, and that causes it to expand. And because cold air can't hold as much moisture, the water vapor that's in warm rising air will condense into liquid, which forms precipitation in the atmosphere, and then eventually falls down to Earth as rain or snow or sleet.
The hardest thing is to get started. You have to get it on paper.
And finally, after air has risen, cooled, and expanded, it's spread out, and then eventually it sinks back down. And we'll see that happen here in the diagram at 30 degrees north and south.
So I'm pausing it here. So these air properties over here, I know y'all have the opportunity to go back and look, but these are the properties you need to know about air, especially when you have to write your FRQs. This is what you need to know. So we're talking cycles, and things cycle because warm molecules will rise. This happens with air and water. So this is the same characteristics that's going to happen with water. Warm air rises, so that's why in a room they have the ceiling fans up there to circulate the air, so they push it back down, and then once it gets up top, it drops, it gets heavy, it drops and comes back down, and then it cools as it drops, gets warm again, and it rises, and this is where we have a cycle. All right, so you have to so remember these characteristics about air.
So these properties of air help us understand the diagram to the left here, which is called a Hadley cell. The Hadley cell is this cycle of air circulation between 0 degrees and 30 degrees, and it's largely responsible for our global wind patterns on Earth. So now that we have our basic properties of air down, which is the first factor influencing atmospheric circulation, Now we're going to introduce the second factor, which is energy from the sun. So because sunlight is most direct at the equator, that's going to cause air here to warm and rise. So we can see that as step 1 in the diagram. As warm air rises, it cools and expands, and because cool air holds less moisture than warm air, the water vapor has to condense into rain. And so if we look at step 2 in the diagram, that's why we see such intense rain at the equator, because that warm rising air has its water vapor condense and then fall down to earth as rain. In step 3, the air continues to rise, cool, and expand further. In step 4, this air is expanding and spreading out even further. And then in step 5, we have cool, dry air is sinking back down to earth right around 30 degrees north and south. And as we can see in the diagram, this is going to explain why we see this predictable pattern of deserts forming all over the earth around 30 degrees north and south. It's because the air that's descending back down to earth here is incredibly dry, so we get deserts. However, we're not quite done understanding the Hadley cell. If we look at the diagram, we'll see that we have this arrow here that's going from 30 degrees back towards the equator. So why is air moving along Earth's surface from 30 degrees back to the equator? Well, we have high pressure at 30 degrees north and south. That's because we have this column of cool, dry air that's sinking back down to Earth, and when a column of air is pushing down on Earth, it gives us high pressure. Meanwhile, at the equator, we have low pressure, and that's because warm air being heated from the sun is rising at the equator. And we know that air moves from high to low pressure, so along Earth's surface, we'll see this air from 30 degrees flowing back towards the equator. That's because we're moving from high to low pressure. Another way to think about this, though, is we have to get back to step 1 of the cycle somehow, and so we need replacement air to come in and fill this vacuum or this gap of air left by the air that's rising at the beginning of the Hadley cell.
The hardest thing is to get started. You have to get it on paper.
So we've covered why air rises and expands at the equator, sinks back down at 30 degrees, and then moves along Earth's surface back towards the equator. But that's only 2 of the 3 factors that determine atmospheric circulation. The third factor is Earth's rotation. So believe it or not, if Earth were standing still rather than spinning, wind would move more or less just straight north and south. Because the Earth is rotating, though, that means that objects such as wind or this baseball we'll talk about here in a second that are traveling through Earth's atmosphere are actually deflected in the opposite direction of Earth's rotation. So another way to try to understand the Coriolis effect is to imagine that you're standing at the North Pole and you're throwing a baseball straight south. So you may be aiming the baseball along this line here, but because Earth's rotation is causing the ground beneath the baseball to spin, the baseball will actually be deflected the opposite direction of the spin. So even though the ball was traveling on this trajectory, it's going to end up here to the left of where you aimed it because the ground beneath the Earth is spinning. Now the same thing is true of the wind between 0 and 30 degrees. So because this air at 30 degrees is moving from a high pressure system back down to a low pressure system, it would flow directly south or directly north in the southern hemisphere. But because Earth is spinning this direction, the wind from 30 to 0 degrees is deflected the opposite direction. So what we get is wind moving from east to west between 30 and 0 degrees. Now, because 30 degrees is a higher pressure area than 60 degrees, wind is also moving from 30 degrees out to 60 degrees. The wind in this direction, though, is deflected in the opposite direction as between 30 and 0. And that's because the Earth at 30 degrees is spinning so much faster than it is at higher latitudes at 80 or even at 60, that the wind is actually going to be deflected in the same direction as Earth's spin. Now that's a confusing concept, so let's talk about this using the example of a treadmill. Imagine that you're running along a treadmill that's going 15 miles an hour, and suddenly you jump to a treadmill right next to you, moving in the same direction, but only moving 2 miles an hour. So it's moving far more slowly. You're going to have so much momentum coming from the 15 mile an hour treadmill that jumping onto the 2 mile an hour treadmill is going to cause you to run forward quite a bit. And so that's why we see wind from 30 degrees to 60 degrees actually traveling in the same direction as Earth's spin. It's because the Earth is spinning so much faster at 30 degrees than 60 degrees that the wind is deflected in that direction of Earth's spin. Now we'll put together all three factors, so the sun's energy, air properties like density, and the Coriolis effect, to take a look at how Earth's global wind patterns are the result of those factors. So the first thing I want to do here is point out that our Hadley cell here still works the same way. We're just looking at it from a side view where we see all of Earth, rather than looking at it from the viewpoint of being on Earth's surface like we did in our first slide.
The real tool isn't made for a moment, but for the years.
So if we look at the Hadley cell, we can remember that the sun's rays are striking the equator most directly. So that's heating the air here and causing it to rise. Then it sinks back down at 30 degrees. And because of this high pressure system at 30 degrees, air is going to be moving out towards 0 degrees and 60 degrees. We can see here that with our low pressure at the equator, our higher pressure at 30 degrees, and then our low pressure again out at 60, we're going to get air moving out from 30 degrees towards 60 and towards the equator. But remember that the air does not move in a straight line. It's deflected based on the direction of Earth's spin. And so between 0 and 30 degrees, we have our air moving from east to west, and we call those eastern trade winds because they used to drive trade from the east to the west because the ships were dependent on sails. This also drives the circulation of the ocean currents in a clockwise direction in the northern hemisphere and in a counterclockwise direction in the southern hemisphere. Then remember that between 30 and 60 degrees, the wind is blowing from west over to the east. And this is because the Earth at 30 degrees is moving so much faster than out at 60 degrees or 80 degrees that the wind is deflected in that same direction as the Earth spins. So it moves from west to east. Now this means that in North America, where we live, we get our weather from the west. So if you're looking at the radar to try to see if we're going to have a snow day, you're going to look over at Chicago and Wisconsin because you know that their storms are headed our direction because we have westerlies or western prevailing winds, which means our weather moves from the western United States over to the eastern United States. Our suggested science skill for Practice FRQ 4.5 today is explaining relationships between characteristics of environmental concepts or models that are represented visually. So I want you to see if you can explain how is the sun responsible for the pattern of air circulation that we see in cycle C on the diagram here. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future APES video updates.
All righty. So coming back to the module. All right, so that diagram that he had that just had labels on it, that's the kind of thing you're going to see on a test. It's just going to be blank. And it correlates with this diagram here. All right, so you're going to have to know what these cells are: Hadley cells, Ferrel cells, and polar cells. And again, he was talking about the prevailing winds, horse latitudes. So you got a lot of stuff going on here. You've got trade winds, you've got doldrums, prevailing winds, and that sort of thing. So you might need to refer to this diagram here to help you with some of the questions. Also, he talked about the equator, the north and south equator. The winds go in opposite directions. So you notice here, the winds are blowing. The arrows are curving to the west, and then on the bottom, they go from the bottom also to the west, but they kind of, it's like a mirror picture. So notice that they are slightly different from top to bottom. All right, so what I asked you to do, so again, I don't want you to do, so the FRQ is there, but what I want you to do today is get a little practice looking at the Coriolis effect. So the worksheet is here. The first part of the worksheet is simply, hold on one second, I got an emergency call. So everybody download that worksheet. All right, the document hasn't loaded. And I'm talking to my class. The document hasn't loaded yet, but it will load. But while you're waiting for it to load, go to the gizmo. So go to explorelearning.com. So let me do this. At least mine hasn't loaded. Just give me a minute. Okay, so everybody should log into that. Let me see if the worksheet is popped up yet. Back over here. Yay, there it is. All right, so you're going to follow the directions on here as you go through the activity. Okay? All right, so download this first and then go step by step for what they tell. So the first part is a warm up, this practice. Just practice an example of what the Coriolis effect would look like. And then after that, after you've practiced, then they're really going to talk about the Coriolis effect. So they're going to switch it to talking about the actual wind patterns on the Earth. So practice with the first activity with the trains. Fill this in. At the end of the activity, let me pop back here.
She also texted me, so. Oh, okay, we're good. Thank you, Cheryl.
Okay, good. All right, so when you finish, don't do the quiz until after you have finished, but there's a 5-question quiz after you finish. Now, this is a long activity, so we'll be doing this today and next week. Okay, make sure that you complete all parts of the worksheet. So again, where's my worksheet? Like over here. All right, so it's quite a few pages to it. So take your time, read each one carefully. Like I said, you're not going to get it all done today. So do not focus on doing the AP classroom or focus on doing this so that you can get this out of the way. If you finish this, then you can do AP classroom and the FRQs. But today I want you to focus on doing the gizmo. Okay, get some practice in. Some of y'all been doing a lot of copying and pasting. You need an activity where you actually have to read and respond. That's what lab work is about. If you were in a classroom, you would have an activity similar to this. All right, any questions? Any questions? All right, I'm gonna stop sharing, make sure everybody's in the gizmo. Let me know if you cannot get in the gizmo. There we go. It took a minute for my worksheet to upload. All right, so everybody should be in the gizmo, I'd like to see this. Gianna, you in the gizmo? Okay. All right, so again, do that first. If there's any questions. All right, I'm going to repeat this again because someone just came in. Okay. All righty. So I'm going to switch back over here. All right, good afternoon, Amelia. We are, go to Canvas first. All right, we're in 4.4. We've already watched the video, and our focus today is the Coriolis effect. So you want to download the worksheet. You want to go to the gizmo, and first around, before you get started, play around with all the buttons so that you know what to do, what's available, what's not available. Just click on things and look at the effects, and then, because that's what the warm-up really is about also, not only to get you to play with the train, but to also get you used to clicking all these buttons and watching the effect of having buttons on and buttons off. Okay, so take a few minutes to do that, and then always reset after each one. So the one that they use the most examples are the merry-go-round. If you were sitting on the merry-go-round and you threw a ball out at somebody, if you threw a ball across to a person that you think is across from you, would they catch the ball? That's always an example that they give, because most of y'all are familiar with how these merry-go-rounds work. And then we switch to looking at the earth, and then we switch to looking at wind patterns. So there are several different scenes that you'll click on as you go through this activity. All right. Good afternoon, Brooklyn. We are doing a gizmo today. Okay. Were you here at the beginning? Because when I just did attendance, you were out. Okay, I got you. I corrected that. All right, so you know what to do? Or do I need to explain? The lab, right? Or the worksheet thing. Both. Okay, let me re-explain just to be sure. Just not a problem. All right, so we are in, if you start in um, the module, the assignment is in the module after 4.4. It's actually after 4.4 FRQ. So that's where you'll find it. The worksheet, so download the worksheet first, and then go to Gizmo through explorelearning.com or Explore Learning, whatever. And then you've been assigned the Coriolis effect. And then you will start with the warm-up activity and then go through and click on all the other, follow the other parts by clicking, changing the scene by clicking at the top. All right, the Coriolis effect is going on because right now I started off this morning in this sweater and it is like 80 degrees outside now. It's about to burn up. This weather is crazy.